In this lesson, we'll learn about the print and cut process, where designs are printed with any device and then transferred to the FCX 2000 to be contour cut. This application can be applied to creating decals, full-colored packaging designs, and more. This lesson will cover the process from start to finish. This includes how to generate a cut path, the steps required to contour cut the print, how to use layers effectively, and how to create registration marks on your design before sending to print. The software we'll be using in this lesson is Cutting Master 4 with Adobe Illustrator CC 2017. While this may not be the software you're using, the steps are similar to other software applications. We recommend also reviewing the manual or instructional video supplied with your software for further instructions. The first step in the print and cut process is to create the cut path. Keep in mind that the cut path should be created after the design is complete and before creating the registration marks. A cut path can be any shape with a thin line and no fill, such as a square, circle, or any other shape such as a square with rounded corners. In cases of making a decal, you may decide that a cut line that contours the graphics design is the best choice. For instance, here we have a design that we can use as a decal. Here we'll create a cut path that contours the design. While we will be using Adobe Illustrator, CorelDRAW has similar steps to create the same kind of contour cut line. The first step is to select all of the objects in the design. Click on the Object pull-down menu, hover the mouse over Path, and select Offset Path. When the Offset Path window appears, enter the distance or margin between the graphic and the cut path. By enabling Preview, we can determine how the outline or offset path will look. It looks a little messy right now, but this will be taken care of in a minute. We can click OK to set the path. Next, click on the Window pull-down menu, and make sure the Pathfinder palette is open. Click on the first button, Unite. From here, let's make sure the cut path has no fill and there's a stroke line. If you need to remove the holes inside the new outline, first release the compound. Hold the Shift key and click on the outline. Delete the smaller object inside by pressing the Delete key. And finally, ungroup it. The next step is to separate out the cut path from the rest of the design using the Layers palette. First, make sure the Layers palette is open. Next, we'll need two layers. One layer that contains objects for printing, and a second layer that contains the cut path. We'll label the current layer Print. Next, create a new layer, and rename the second as Cut. We'll assign the cut path to the cut layer by clicking on the cut path and dragging this dot to the cut layer. This will assign the cut path to that layer. To check this, we can briefly turn off the print layer, and this should leave the cut path. In order for the cutter to follow the cut path accurately, registration marks have to be placed on the design. Registration marks provide information to the cutter for precise cutting. Once the marks are scanned, the cutter determines aspects such as the starting point, angle, and any distortions. Since Cutting Master 4 is a plug-in module for Adobe Illustrator and CorelDRAW, it can create and correctly place registration marks directly within these applications. This is done by clicking on the File pull-down menu, hover the mouse over Cutting Master 4, and then select Registration Marks. If you are using CorelDRAW, click on the Launcher icon button and then select Registration Marks. In either case, this same window will appear. At the top, we have the choice of registration mark styles. Let's take a brief look at the different registration mark styles and their purposes. There are essentially two main types of registration marks, Type 1 and Type 2. There is only one simple difference between them. With Type 1, the registration mark corners are facing inward, and with Type 2, the registration mark corners are facing outward. While either will produce the same end result, this choice is generally made depending on the distance between your design and the registration marks, as well as available media space. Segmented registration marks are primarily used for longer cut jobs ranging from 3 to 50 feet, and determine if any bowing occurred in the printing process. Segmented patterns can be used with any print and cut job for the FCX 2000, but won't usually be necessary. The remaining choices determine the number of registration marks used, such as 3 points and 2 points. Now that we understand a little more about registration marks, let's examine the different pattern choices that Cutting Master 4 offers on this pull-down list. Here we are given several choices that we just discussed. In this case, using Graphtec 4 Point Type 2 will give us the best accuracy without sacrificing time to scan the registration marks on the print. You may decide to use 3 point or even 2 points depending on the size of the design. Generally, the smaller the design, fewer registration marks are needed. Now that we've chosen our registration marks, there are other settings that affect the look of the registration marks. Units determines whether values are set to inches, millimeters, or centimeters. The other settings are used to change the shape and location of the registration marks. For instance, when placing the registration marks, margin is the distance between the cut path and the registration marks. The values of the registration mark thickness and length can also be adjusted. It is best to increase these values for longer prints or for prints that have been laminated. In either case, increasing these values makes it easier for the marks to be located by the sensor on the cutter. When segmented registration marks Type 1 or Type 2 are chosen, X step becomes active. This is where the distance between each intermediate registration mark can be adjusted. X direction determines the X direction of the design. Keep in mind that the X direction is going from side to side on the flatbed, and the Y direction is the up and down direction on the flatbed. Convert to rectangle is a useful function that will convert the corners of a selected rectangle to form registration marks around your design. This will be demonstrated in a moment. Relative to page, we'll place the registration marks on the corners of the page. Once this setting is checked, the margin value will be the spacing between the edge of the page rather than the design. Align document with registration marks aligns the document's origin or 00 point with the lower left registration mark. Use reverse color registration marks places white registration marks within black squares. When selected, a margin value will determine how far the black rectangle spreads out from the white registration marks. Reset simply resets the registration mark settings back to default. The barcode settings will be covered more thoroughly in the lesson Advanced Cutting Operations. Use trim marks will use trim marks provided within Adobe Illustrator and Corel Draw. When the settings are to our liking, clicking OK places the marks on the drawing. Let's press Ctrl-Z or Command-Z on the Mac and start over. Let's draw a rectangle large enough to surround the design, but close enough so there is no wasted space. And then open the registration mark window again. Notice this checkbox setting, Convert Rectangle. When enabled, it uses the four corners of the selected rectangle for placing the registration marks. This feature allows us to choose exactly where the registration marks should be placed. The only criterion is that the rectangle has to be selected beforehand. Also, when using this feature, make sure the registration marks do not cover the cut path or the design. Click OK to place the registration marks. The rectangle is then converted using each corner of the rectangle as a registration mark point. When placing the registration marks using this method, make sure there is at least a ½ inch distance between the rectangle and the edges of the sheet. The design is ready for printing, but first we have to disable the cut layer so it doesn't print with the design. When loading the print onto the FCX 2000, getting the correct orientation is essential. The easy way to determine this is by opening up the Cut Plot window for Cutting Master 4. Within Cutting Master 4, there are these red and blue arrows here. These are the same arrows in this little icon of the FCX 2000 at the top of the window. If we took the icon and placed it next to the job, it would lay out like this. So the corner where the arrows start would be where the control panel is located. Thus, to overlay the cutter, it would look like this. So keep in mind that the right edge of the preview is the bottom side of the bed on the table. As you use the cutter more and more, this will become apparent. Load the media with the correct orientation. Hold the media in place by turning the vacuum on. Switch to the condition you plan to use. When sending a print and cut job, the print layer has to be turned off. Otherwise, the software will send the objects that were printed to the cutter. To do this, click on the Layers tab and click on the check mark next to the print layer. Once the Cutting Master 4 options are set, click Send. When the job starts, the FCX 2000 sensor automatically starts searching for the first mark. Once it finds it, it will continue to find the other marks automatically. Once all the marks are found, it will start to cut the media following the adjusted cut path. In the lesson on conditions, we learned how condition presets can be assigned to each layer. To demonstrate how this can be helpful in the print and cut process, we have a package design that has both cut and crease lines, with each condition being assigned to tool holder 1 and tool holder 2 respectively, with appropriate tools mounted. If we look at the design's layers, there are 3 different layers: the crease layer, the cut layer, and the print layer. On the cutter, condition 2 has been configured to cut, and condition 3 has been configured to crease. The registration marks have been placed, and the printed media has already been loaded on the FCX 2000. Let's click on the File pull-down menu, hover over Cutting Master 4, and click on Cut Plot. Once the Cutting Master 4 Cut Plot window opens, we can click on the Layers tab to set them up. The print layer has already been disabled, and both the cut layer and crease layer are enabled. We can then assign each layer to a condition. In this case, we want the cut layer to use condition 2 and the crease layer to use condition 3. Take note that the crease layer is in the top position. This is because it has to be processed first. To assign the crease layer to condition 3, we first make sure the crease layer is highlighted or selected. Next, click on the Enable Driver Options checkbox. We click on the preset FCX 2000 number 3 plotter condition. As it is selected, the options below confirm that this preset is set to condition 3. Let's select the cut layer and assign condition 2 plotter condition to it, since it is assigned to condition 2. When the software sends the design to the FCX 2000, it will first switch the cutter to condition 3 and process all of the lines for creasing. After all the crease line data is sent, it will switch the cutter to condition 2 and then send for all the lines in the cut layer using the cutting tool in tool holder 1. Once again, always pay attention to the stacking order of the layers. The uppermost layer will be sent to the cutter first. If you need to switch the order, you can use these green arrows on the side. Let's click on Send. The next message is ensuring that we have loaded the media. In this case we have, so we can press OK. Once the job is sent and the cutter reads the registration marks, the software has the cutter switch automatically to condition 3, configured for the crease tool, and the crease lines are processed. Once the crease lines are completed, the software then has the cutter switch to condition 2, the condition configured to the cut tool, and the cut lines are processed. And here's the result. Cutting Master 4 conveniently allows virtual condition presets to be configured. Instead of the software using the conditions within the cutter, the software will send the preset condition settings, force, speed, acceleration, etc., to adjust the cutter settings. There are two big benefits to using virtual condition presets. 1. You can configure an unlimited amount of conditions, not limited to the 8 conditions on the machine. And 2. The conditions can be labeled for easy identification. For instance, there may be different types of chipboard or different manufacturers, where more than condition configuration is needed to process. With Cutting Master 4, there can be a configuration for each thickness, manufacturer, etc. As an example, let's create two new virtual condition presets, one for cutting chipboard and one for creasing chipboard. Let's start with the creasing condition preset. Let's create our first virtual condition. We will have to set the value first before we label the virtual condition. Notice that among the settings for a condition preset, a tool type is not available for these virtual conditions. This means that when creating the virtual condition preset, it should be assigned to a condition that has the right tool type and is assigned to the proper tool holder. In this example, the crease tool has been assigned to condition 3, because that condition is set to a creasing tool and is assigned to tool holder 2 where the creasing tool is mounted. When doing this, you should make sure that the creasing condition settings are configured as well, including the type of crease line, repeats, and so forth. At the same time, the cutting tool has been assigned to condition 2, because it is assigned to tool holder 1 where the cutting tool is mounted. First, we'll set the condition number to condition 3. With that in mind, we'll change the force value for creasing to around 70, and the quality, which refers to the acceleration, we can set to 1. The speed should be set to around 25. To save this condition preset, click on this pull-down list of condition presets, scroll to the bottom of the list, and click Save As. Enter the new name, which in this case we'll label it Chipboard Crease, and then click OK. The next condition preset is for cutting chipboard. Once again, we want to change the settings and then save the preset. We can start with selecting condition 2. We'll leave the speed to 25 and the quality at 2. But we need to set the force to 40. These values are determined through prior testing of the material we plan to cut. This condition preset may now be saved. Once again, we click on the condition preset lists, click Save As, label it Chipboard Cut, and click OK. These two new conditions can now be assigned to the two layers of the design. Now we can go ahead and select the crease layer, assign the virtual condition preset Chipboard Crease to it, then select the cut layer, and assign Chipboard Cut virtual condition preset to it. We can now send the job to the cutter. The last function we will discuss provides better accuracy when scanning registration marks. Intelligent Scan Mode, or ISM, helps the scanner detect marks on harder-to-read medias such as lamination, high gloss, and reflective by using a more extensive search algorithm. To enable ISM, press the pause menu key. Press the 2 key for arms. Press the up arrow key twice to page 4 of 5. Press the 3 key for sensing method. Press 1 for ISM. Press enter to set the value, and then press the pause menu key to set the cutter to ready status. Again, this function is only necessary for media where the sensor has trouble detecting marks. This concludes the lesson on print and cut operations. Our next lesson will discuss a few powerful advanced functions of the FCX 2000.